Hello, everyone. This session, we're going to look at 3.5 Part 2, Rational Functions. Now, if you haven't reviewed the 3.5 Part 1, Rational Functions, please make time to review that video because it's the two sections are related. Okay, for this video, we'll look at identifying horizontal asymptotes and also determine what value a function approaches as x approaches a given value. Okay, so the first problem that we'll look at is finding the horizontal asymptote of f of x equals 10x squared over 6x squared plus 5. Now, horizontal asymptotes are, horizontal lines, horizontal lines that a function is approaching as x approaches infinity or x approaches negative infinity. And so if we look at this function here, 10x over 6x squared plus 5, there are three cases for horizontal asymptotes. And for those cases, you always have to compare the degree of the numerator and the degree of the denominator. Remember, the degree refers to the highest exponent. And so in this case, here, the degree of the top, I'll call it D, the degree of, or N, the degree of the numerator is 1, and then the degree of the denominator is 2, so that's the biggest exponent here. And if your degree of the numerator is smaller than the degree of the denominator, right, 1 is less than 2, your horizontal asymptote is going to be y equals 0. Okay, so that's the first case. And let's look at the graph just to show you what that looks like on a graphing calculator. And so I already have my graphing calculator pulled up here. Okay, so I have one, I typed in 10x over 6x squared plus 5. And if we graph this, you can see how over time, the y value, right, you can see how it's approaching 0 for the y value. And also, as you go towards negative infinity for x, it's approaching 0. So the horizontal asymptote, if I were to draw this in even on the graph, okay, it would be this line right here. You can see how overall the graph approaches the horizontal line at y equals 0. Okay, let's look at number 2. Find the horizontal asymptote of g of x, 10x squared over 5x squared plus 5. Now the degree here is 2, so the degree of the numerator, the biggest exponent, is 2. The degree of the denominator is 2. So in this case, they're equal, right? The degree of the numerator is equal to the degree of the denominator. Then your horizontal asymptote is going to be the quotient or division of these asymptotes, not asymptotes, I'm sorry, coefficients. So it's going to be 10 divided by 5, which is 2. So the horizontal asymptote is y equals 2. So in general, if your degrees are the same, you're going to take the coefficient of the numerator, which is called a, and divide by the coefficient of the denominator. So let's look at this example here on the graphing calculator and see what it looks like when a horizontal asymptote is y equals 2. Okay, so let me check that. And I've already typed in 10x squared over 5x squared plus 5. If we graph that, you can see over as it approaches infinity, it approaches 2. And as x approaches negative infinity, it approaches 2. So if I were to draw, right, a horizontal line at y equals 2, it would be this line right here. Okay, you can see how the horizontal asymptote is at y equals 2. Okay, let's look at a third case. Okay, what happens though if for this case, g of x is 10x to the third over 5x squared plus 5. Your degree of the numerator is 3, and the degree of the denominator, and I'll call it d, 2. So in this case, the degree of the numerator is bigger than the degree of the denominator. And when your degree is the exponent up top is bigger than the exponent of the bottom, you say there is no horizontal asymptote. Okay, so there's no equation, there's none. And we'll just go over the graph again. Okay, so for some of the older models, you might not have this option of putting it in fraction form. I have the 84 plus CE, where if I do alpha and then press this button on the right-hand side, it gives me a option to do it in fraction form. If you don't have that button, you just have to type it out as 10x to the third divided by, make sure you put parentheses around 5x squared plus 5. If you don't, your graphing calculator only thinks the 5x squared is in the denominator. Okay, so let's go ahead and clear this out and graph this one, the third equation. And you can see how there is no horizontal asymptote, right? There's no straight horizontal line that the graph is trying to approach. It does look like it has a slant asymptote, but we won't look into that. We'll only look at horizontal and vertical asymptotes for this section. Okay, so let's go back to the page and do a summary of the 3 types. Okay, so if you have some function where you have some function ax to some degree plus the other things are irrelevant, divided by the coefficient bx to some degree, I'll call it d for denominator, plus the other things are irrelevant. The first case is when the degree of the numerator is smaller than the degree of the denominator, then your horizontal asymptote is y equals 0. Okay, for the second one, if your degree of the numerator is equal to, I think that was a second case, if they're equal to the degree of the denominator, then your horizontal asymptote is the division of the coefficients of the leading coefficient of the numerator divided by the leading quotient of the denominator. If your degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. You can also confirm by graphing it on your graphing calculators. So this is the 3 types of horizontal asymptotes of a function. Okay, now let's look at the next case. What happens as, let me space this out, as x approaches some value, where does the graph approach? Let me space that a little bit. Okay, so for A, and we have this graph here, it's a rational function. You see there's vertical asymptotes. The vertical asymptotes you can see are at -1 and +2, and there's also a horizontal asymptote right here at y equals 0. So I'll label them horizontal asymptote at y equals 0, vertical asymptote at x equals -1, and x equals +2. Okay, so we're interested in what happens as x approaches -1. So here's -1. And then here it looks like a negative sign where the exponent's supposed to be. So this tells you direction, right? Because you can approach -1 from the negative side or coming from the left, or you can approach -1 from the positive side, coming from the right. So this tells you where, from which side it's coming from. So this is saying it's approaching -1, coming from the left, coming from the negative side. So you're approaching, use a different color. We're approaching -1 from this side. So what happens to the y value? What is the function doing in terms of the y value? While you're approaching -1 from the left side, the y value keeps getting bigger and bigger and bigger and bigger and keeps going, increasing towards infinity, because the y value gets higher and higher and higher. So as x approaches -1 from the negative side or the left side, f of x, or the y value, approaches infinity. Okay, so let's see for part B, what happens as x approaches 2, right? 2 is here. 2 from the negative side again, coming from the left negative side. So as approaches 2, I'm going to start here. And you can see as x approaches 2 from the negative side, it's also approaching infinity. The y value is approaching infinity. Now, what happens if you're approaching -1 from the positive side or the right-hand side? So I'm coming from this way. So I have to go on the graph. And as you approach -1 from the positive side, the y value is approaching negative infinity. Okay, what happens as x approaches 2 from the positive side or the right-hand side? Coming from this way again. I'm coming from the positive x values. So I'm approaching 2. And what's the graph? The function is approaching negative infinity. And when I say the function, I mean the y value. Okay, what happens as x approaches negative infinity? Okay, so x approaching negative infinity. Remember, negative infinity is on this side, right? Negative infinity. The positive infinity is on the right-hand side. So as x approaches negative infinity, you can see the y value is approaching 0, because that's the horizontal asymptote. As x approaches positive infinity, right, it's going towards the right, the f of x value is approaching 0. Okay, let's do another graph, because this can be confusing at the beginning. So I have another graph here for us. Let me just make it a little bigger to space it out. Okay, so we have this rational function here on the right. And let's look at part A as x approaches -4 from the left side or the negative side. You can see that I'm approaching -4 from the negative side. So I'm approaching this way. So I'm approaching -4, the x value, the function, then the y value, right? The y value keeps going up. So it's approaching positive infinity. Okay, now let's approach -4 from the right side of the from the positive side, because this is a plus sign. So this is saying it's approaching -4 from the right-hand side or the positive side. So I'm approaching -4 from this side, and the y value, you can see it keeps going down. So that's negative infinity. Now let's see what happens if we approach 4. Here, +4 from the left or the negative side. So it's approaching 4 from the left. You can see how the y value is approaching negative infinity. Now, if we look at the part D, we're approaching 4, +4 from the right-hand side of the positive side. Then we have approaching 4 from the positive side. So we have positive infinity. And now we look at, okay, what happens as x approaches negative infinity? Negative infinity, we approach negative infinity. You can see that it approaches the horizontal asymptote, and the horizontal asymptote is y = 1. So the y value approaches 1. As we approach positive infinity, as x approaches infinity, what happens to the y value? Well, if we approach positive infinity, you can see that it approaches a horizontal asymptote at 1 again. Okay, let's see what happens when we are approaching 0. So 0 is right here. 0 from the negative side. So if we approach 0 from the left-hand side, we can see that the y value, it's getting closer and closer to 0. As we're approaching 0 from the positive side, you can see the y value is also approaching 0. Okay, so I hope that gave you a good overview of horizontal asymptotes and using graphs of rational functions to see what the function approaches as x approaches a certain value. As always, please feel free to email me or contact me with any questions.